Good morning, everybody. How's everybody doing today? Happy Tuesday. Alrighty. Sweet. Let's give that a pause. And look at that, I got NetBeans going. Sweet. So we got a couple things today. We're going to get started on exceptions today. And then I want to give you last semester's midterm. So you can get a little bit of practice and see what that looks like. What kind of questions and things from there. Don't forget we do have the quiz finally from chapter 7 to 10. I got that posted. That is available out here in quizzes. So our chapters here, we're going to make up some of the half the midterm or so. So we got 11, 15, we got 7 to 10. And then we'll have exceptions as well from this week. So I'll post the exceptions quiz this week. So that'll be the half the midterm portion here. So this is due on Thursday. Hey, Rochelle. So I apologize. I'm still getting over a cold that I picked up. And yesterday, I thought taking cold medicine would help. And then I'd be able to do classes and stuff. And it did help me feel a little bit better. But I was super loopy from the cold medicine. So I'm trying not to do the cold medicine so that I'm not so loopy. But yesterday was shot, so I did not finish grading these things for you. I'm sorry. I'll be getting those done as soon as I can here to get those projects in. So sorry for the delay on that. Hopefully tonight, we'll see. Still going a little slow, so we'll see. But we'll talk about exceptions, and then we'll do the midterm last time, and then we can go from there. Does that sound like a good plan? Maybe? Alright. Now let me fire up a new project. So opening one. Alright, so there's two parts to exceptions. Oh yeah, the lab. We can do that too, Kaiser. Yeah. Wait a second. Let me pull this one up here. Maybe a little more coffee. Yeah, so the unit test lab. Okay, there we go. Grab that one. So that was lab 6. All right, start on lab 6. I gotta go put this in the right folder here. Documents and GitHub. Somewhere in here. There it goes. Come on. No, come on. Come on. GitHub. There we go. And then 2151 for winter 2022. There we go. All right, lab 6. So we're going to write our class for item. Has properties for name, quantity, and price. Include get methods for everything. A toString method that overrides and returns the name and price. We're going to have purchase given an int quantity that returns a Boolean value if there are enough to purchase. Update the quantity of the item, subtract the number purchased. And if you try and buy too many, don't change the quantity at all. And then we'll add unit tests to ensure 100% code coverage, both cases for purchase, and the constructor gets in toString. All right. So the idea here, right, that we want to be checking to see, we know purchase can return a true or can return a false, if you're able to buy the item or not. If we could buy it, we'll change the quantity. If we can't buy it, the quantity doesn't change. So we have two different things happening there. We're going to check the name, quantity, and price. Now, if there's not, if there's not a set method for these here, there's no way to change them, then that should kind of trigger something that says, oh, well, I probably need them in the constructor if there's not a set method. So I can't just make an object and then go set value. So these need to be passed to the constructor. That's this testing the constructor thing. Let's see. There we go. All right, we'll get rid of some of this here. We'll make our class. We'll add a new class for item. We'll have a name, a quantity, and a price. That corrupt. So private string for name, private int for quantity, and then private probably double for price, right? Because we want to deal with decimal places, you know, $1.99 or something. Probably works out pretty well here. And then let's let NetBeans write the rest of it for us. We'll say insert code given a constructor, and the constructor we want to pass all of these things because we don't have set methods. So we need a way to give them to the object. There's a constructor, and then we'll add all the get methods here. So we'll add some getters. We'll add getters for everything. And then we want to override toString, so we'll add this add override, right? So we can get the compiler to check it for us. Public string toString. So it depends on your objects. So if your constructor, hey Hector, thank you so much for donating those bits to the Student Scholarship Fund over at the College of Engineering and Computer Science at the University of Michigan, Dearborn. Oh, I did it backwards. That's weird. Sometimes it's easier to deal with and make objects that don't have constructors. A lot of it depends on what you're using your objects for and whether or not these sort of properties should be mutable or immutable. So a lot of it's like a design or having to do with what your objects are representing. So in our case, it probably would make sense to have a method to change price, but it's, you know, our lab was just kind of practicing some of the basic stuff here. So if you can set the price, right, if that's changeable, or change the quantity, if that's changeable, right, those sorts of things. Maybe even name here, right? We probably have like a SKU. I don't know. It depends. I don't know if there's an ideal way or not, because I think it depends on the object. But that's how I view it. All right, and then the toString then, we're just going to return the name and price here. So we're going to return name plus maybe a $, or a space there, right? Plus the price. And add those in. It's not the prettiest, but that should be okay. There's our toString, right? And then we're going to try and add a purchase method, right? So that given a quantity. So, and it's going to return a Boolean value. So it'll be public Boolean purchase given an int for quantity. Now we have the quantity argument and we have this quantity. So if you want to call this like quantity to purchase, maybe that makes more sense. And we can say, hey, if our quantity to purchase is greater than the quantity, then we can just return false. Nothing happened. Right? If you try and buy that many, we just no, we're returning false. Nothing happens. We're told you no. Otherwise, we'll take our quantity minus the quantity to purchase, and then we return true. Now, I don't have this in an else because it's a little bit redundant, right? If you're returning, the method stops. It's just done. Nothing happens after that. So it's else is like implicit here that if this code is going to run, it's because this isn't true. We don't really need that if else to break that up. Okay, so that is our class here. So we're going to right click and say navigate, go to test. Now make sure it's JUnit 4 because the JUnit 5 stuff or the latest doesn't play well with Ant, unfortunately. So JUnit 4, and we should be able to say OK. So the idea with code coverage, when we said we want to get to 100% code coverage, what that means is while my unit tests are running, right, I want every single line of code inside of this class to run. So if I have a block like this, I want to make sure that this line of code runs and then that these lines of code run. So I need at least 2 different tests then for purchase. I think 2 ought to do it, but right, so I need one that the if block runs and one that it doesn't run here. And then we can test the the constructor separate. So sometimes you get a bunch of these ones here. Oh, thanks so much for following along. I don't like testing gets all by themselves. I think that's kind of boring here. So I'm actually going to get rid of all of those. Actually, let me save the top one here. I'm going to get rid of testing all those gets. I'm going to actually just call this one test constructor. And I'm going to test them all at once. Right? Because testing them individually, at least for just gets, I think is a little bit overkill. We should be okay. So we're going to do our AAA format. We're going to arrange, we're going to act, and we're going to assert. Okay? So to arrange, we're going to set up all of the variables that we need in order to test this. Right, so we're going to have a string for the expected name. Let's make this coffee, because we've got to have our coffee. Trisaurus. Couldn't rediscover how you created your tests and NetBeans quickly enough. Oh my goodness, I'm sorry. Yeah, just shoot me a message next time, or ask in the Discord, or I'm sorry. So there's nothing like super magical about the right-click navigate go to tests, but it does put it in test packages, which is nice, and then it like kind of builds it all out for you here. It's generally pretty nice, and it's in the same package here, so we don't have to do imports separately. But because it's in a separate like source package and test package here, we actually go and build our project. It excludes all the test stuff, which is nice too for like when you are actually delivering code and things. We don't care too much for our purposes, but keeping them separate in that way is nice. All right, so we'll have our name, and then we'll have a int for expected quantity. And you need lots of coffee, so let's have like 42 coffee. I don't know what sort of unit that is, but that's okay. And then we'll have a double for expected price. Is going to be, let's make these cheap here. Let's just do 99 cents each, because we want some cheap coffee. You can't have too much here. Right, and then an act is we're testing the code, or we're running the code that we want to test. Oh, and let me do one more, a expected toString. Let's test that same thing at once. So that would be coffee for $1.99 or 0.99, because we can test all of those at once. The toString is very similar to a get method. I think testing it as part of the constructor is fine here. If you make a separate method for it, that's great. It's probably more proper, but again, we're going to go for easy-ish here and still try and get the things done that we want. So now in act, the code we're testing is the constructor. So I'm going to make an item. We'll call this item equals a new item, given my expected name. No, expected name, given my expected quantity, and given my expected price. And then we'll have a string for the actual name. Right, we're going to go ask the object, what do you think your name is? So that's my item.getName. We'll have an int for the actual quantity, item.getQuantity. Right, and this is just going to help make sure we don't have any typos. We didn't return the wrong variable different places. They're not very interesting tests, but it is easy to, when you're doing these, if you're doing it by hand, put the wrong order in, or change some of these around here. So it's auto-generated, so it probably should be fine, but and it's nice to have here. And then a double for the actual price, item.getPrice, and then a string for the actual toString or something, item.toString. Okay, so that's all the code we're testing here. Right, we did the constructor, and then we're getting out the values. And then we're going to assert that they match. So we'll assert equal the expected name and the actual name. We'll assert equal, assert equals the expected quantity and the actual quantity. Yeah. We'll just copy paste at this point. So we got 2 more to go. The expected price and the actual price, and then the expected string and the actual toString. Now, remember, when you're dealing with doubles here, this one needs to change because Java's bad at arithmetic. Remember, sometimes you get those trailing millionths or billionths or whatever. So with a double, when you're asserting equal, you need to include that delta value. Like, how close is close enough? I'm just going to put a bunch of zeros in. Like, they should be identical, but as long as they're within like a millionth or so, we're going to say that's close enough. Okay? Especially like if we said, hey, I want to buy a certain amount, and it's going to cost so much value, like we're going to buy 10 and multiply it. Sometimes it's bad at math. So getting within a million should be okay. I'm going to right click and run it or test. Either one will actually run those tests. And we get test purchased, passed. Test constructor failed. Uh-oh. We expected, so this is, the message is a little hard to see here, sorry. It says expected coffee, $, 0.99, but was coffee, $, 0.99. So it's trying to point out this little braces area is where the discrepancy was. So we got 0.99. Well, that's my mistake here on my expected, right? When we return a double, you get 0 point something if there's nothing on that side of the decimal place. Right, so my test here was wrong. It should be like this. Right, that's my mistake, so let's run it again. We'll test it. And now it passes. Now you notice test purchase passes, but it's empty. So if it doesn't fail, it passes. So sometimes people will put in here assert fail or assert. Where is it? There's like a built-in fail. Yeah, they just fail. Right, it just fails the test until they went and put it in. Because when you just right-click and run your test, if you're not paying attention, you're like, oh look, all my tests pass, I'm done. When you forget to even check that it's empty. So now, like, hey, failing by default is kind of nice here. But now here we'll have two different purchases. We're going to have successful or returns true, and then we'll have another one where it returns false. Okay. So what we want to do, let's do the returns false first. Excuse me. So what I want to have then is a Boolean for the expected result. We said it was going to be false here. And then I also want to have a quantity. So I want to check that the quantity doesn't change. Right? Now, in my arrange section here, right, we're going to actually make the item that we're testing here. So I'm going to make an item equals a new item, new item, okay, given, I don't know, the name doesn't matter, so an empty string is fine. We'll give it the expected quantity, and then a price. The price doesn't matter either, so I'm just going to give it 0. Because we don't really care about either of those. And then in our act section, right, we're going to say my Boolean for actual result is equal to item.purchase, and let's try and buy 50 of them. Or we can do like expected quantity plus 1. Let's do one more than the quantity that we have. And then we're going to have an int for the actual quantity. So if you didn't do these get quantities, that's okay. For the false, it's fine. When it returns true, we should be checking to make sure that the quantity changed by the expected value here. So I'm just putting it to make sure that it doesn't change, right, when we assert, just to make it easier when we go copy paste. And now with the Boolean, you can actually just say assert true or assert false. If you want to save yourself a little bit of typing, so you don't need to say, assert equals a Boolean result and true, right? If you just want it true or false, you can just use one of those as a shortcut. It's just so you'd have to type a little bit less. It's okay. And then we can assert equals our expected quantity and the actual quantity. So I don't actually use this expected result, right? Because I can just say assert false here, right? I don't need to have that here. Nope, and that's assert equals, not array equals, just assert equals. Right? Now I'm going to copy that one into returns true. So if we have a quantity, right, and we go buy some number of them, okay, you had to fix some things, yeah. So if we have, let's say, 50 of them, and we go buy 8 of them, the new quantity should be 42, and we should be able to get back a true that yes, we were able to buy 8 of them because we started with 50. Right, so let's run our tests. We're going to say, okay, that told me it was okay, we had enough to buy, and then the quantity successfully changed, and we get our tests passing. Ooh. That one feel okay for item and item tests? For our lab, let me go commit that to GitHub here. All right, let's find 2151. There we go. All right, so here's lab 6. So for a very basic class, they probably don't feel like they're all that useful. But as things get more interesting and more complex, they're super helpful because all of the testing that we're doing or that you would be doing, like when you go run your program and does my code do what it's supposed to do, we're putting into code so that the computer can check it for us. Because remember, humans are really bad at, I expect a certain output, let me look and see if that certain output showed up on the screen. And really, when you do your testing, you're essentially doing this sort of stuff anyway. You're just doing it like in your main method. You'd say, hey, let's make an item, let's get a result, and let's print out the result. And then we'd have to throw all that away, right, in the real world because that was just test code, where we get to keep it here. And then the other piece of that is once we have the unit tests, we can make the computer do it for us. And there are tools called continuous integration testing tools or continuous integration engines that they watch your source control. And anytime code gets committed or changed, it will go and run all of the tests. So as you're making changes to code and you're building new features or enhancing things or changing whatever, all of those tests are going to run, and you can see if you changed something and it broke something. Because most of the time when you're dealing with software, it's going to have some sort of life cycle, right? And maybe it's possible that you build something and then you never go change it again. But most software, once it gets built, people want changes to it. Right? It does a task and then, okay, great, that's fantastic. What can we do next? Right? What else can we do with it? Why is it not doing anything here? So as you start making changes to it, all those unit tests are going to stay there and keep running to make sure that as you change things, it still does all those things that we expected it to do. And again, this is only the level of unit testing, that the individual class does something as it expects it to do. There's another level of testing where you can write integration testing, where your classes actually talk to each other. And we're testing that the class interactions work well. Or there's end-to-end tests or system tests, right, that test everything, the whole scope of the project. And the more tests we have, the more we can automate that sort of thing, the better we feel about changing it. So it's generally a very useful tool to have and a very good goal. Some people think it's silly because it takes maybe a little bit more time, but I would definitely argue that any code that's worth writing is worth testing. Because who wants to pay you to write code for a given product and not be sure that it does what it's supposed to do? Right. So if we're going to test it, we might as well let the computer do all the testing for us here, rather than us write a bunch of stuff in main and have to eyeball it. All right, and let's push. And let me go grab last semester's final exam here. I'm actually fading fast still, despite sucking down all this coffee here. Not feeling so hot still. Let's see if I can find this one here. All right, midterm. So it uses different quiz questions because we used a different book last time I taught this class. So the quiz style questions are gonna look a lot different here, but I want to show you the long answer style questions here. All right. Maybe that's more useful here rather than posting the whole one. Oh man. Yeah, I'm not feeling hot, folks. I'm sorry. So let me go to our content here. So in this midterm section here, let me just add a file, and we'll look at a practice here. This is practice midterm. So there'll be 15 quiz style questions on the same test bank. So you might get the same one because I'm just pulling them all out of the test banks and I don't have a way to give you ones that you haven't seen before, but you might not. So with that same test bank style questions from those will be in there, and then you'll get 3 long answer programming questions. Now, I hate doing these on a given timed setting here, and sometimes when we have these classes, they're split like we have here. There's 2 sessions a week. Other times there's just 1 session a week. So generally it's designed to be 4 hours or so. You could do it all in one night. Because I hate hey, give you a test and then you have to come back 2 hours later because you might have finished it. Or the other option is you're sitting there listening to new stuff that won't be on the test, and then you can take the test in 2 hours, and then none of those are fun options. So generally I aim for that you can do it in a single sitting sort of thing. So some example questions then were something like this. Let's do let me paste this in. And so this is so a question on classes and testing was something like this. And can I format that nicer? I don't know. Let's do this one here. Let's do this with maybe a nice heading. Make that a heading 3 or something. There. So the question write a class for subsandwich. Subsandwich has an array list of type string to store the ingredients, an integer value for length, an integer value for number of included ingredients, a double for base cost, and a double for price per extra ingredient. We're going to write a method add ingredient that accepts a string, adds it to the array list of ingredients. Add a method get total cost that returns the base cost plus the price per ingredient times the number of ingredients over the included number of free ingredients. So we're going to say, okay, hey, maybe you get 3 free ingredients, right? Or 3 included ingredients with a base sub. And then if you want to keep adding more things, we're going to start charging you more. Kind of like a pizza, right? You can get 3 toppings for free, and then every topping after that costs you more money. That sort of idea here. So you can go nuts with it. So it's not how Subway actually does it, right? We're just kind of mixing and matching the ideas here. This is more like the pizza shop style. Or maybe you just get 1 free ingredient. You get 1 topping, and then every other topping costs you money. That sort of thing. I mean, so Subway doesn't let you put other meat on, where when you're building out a pizza, you can put all the different meats on. And generally, I think those are the more expensive toppings. I feel like it's kind of silly for them to charge you $1.50 to get some mushrooms on your pizza when mushrooms don't cost a whole lot. But, I don't know, the one vegetarian pizza we usually order is it feels bad. It's the same price as the meat lovers pizza that my son likes when I get the vegetarian for my daughter and myself. But that's okay. So that's what we're doing with our sub sandwich. And then we're going to write a unit test for get total cost. Making sure we get the correct cost out. I didn't even ask for specifically for 100% code coverage. Just write a unit test for it here. Sure. It'd be nice if you were doing one that had some number of ingredients added here, but if you just wrote one that had the base cost with no ingredients, that would technically suffice as a unit test for this one. But that's just this example question. So I'm more likely to ask you like 100% code coverage tests for something like a get total cost. That's not okay? So maybe we'll say tests get total cost to ensure 100% code coverage. And really just of that method. We don't really care about the constructor one. That one's not as interesting. So then you'll have to turn in the sub sandwich class and the test methods. You can either copy paste them into the D2L box, or you can commit them to GitHub somewhere and send me a link. Either way is fine. Whatever you probably copy pasting might be even easier because then it's just done in there and done. Okay, so that was like one question. And then another one here. Let's see. We do. This is an inheritance question. So I put that in. It's like a little header here. Oh, whew, I'm fading. So let me do the stuffed animal class here. I committed it to the repo because I thought that was easier, but I think I can just put some code in here. So let's, oh my goodness, that's an ugly copy paste. One sec. I'll put in there like Notepad first. Okay. There we go. This, I think I can do this pre-formatted code. There we go. You can have a code format. So you can write a class that extends stuffed animal. So here's your abstract class stuffed animal. It has a Boolean for battery has power, which was marked as protected. Or protected is that in-between status, so that our child classes or subclasses have access to it. It has a constructor, right, given a name, and it just sets battery has power to true. Private string for name, public string for get name, public void change battery, sets battery to true, does battery have power, returns the value, and an abstract string make noise. Okay. When making noise, if battery has power is true, return a string that includes the name and appropriate animal noise. Otherwise, return an empty string. After the noise was made 10 times, set battery has power to false. That's our stuffed animal. We're making a particular kind of stuffed animal, right? That's going to make a particular noise. Right? Up to you to how you wanted to implement that with your subclass, but you have to implement the make noise method that does this thing where it makes noise a certain number of times. Okay, that was the inheritance question. And then, no, hang on. Oh, goodness. Go back. Click the wrong button. There it goes. And then we're going to write a file IO question. File IO, make that a heading. That said, write a program that allows a user to create a subsandwich and save it to disk as a binary file. Now, this one didn't ask you to go and read it, so I'm probably also going to include an option for reading. So I'll just add that now. An option to load a subsandwich from a file. Right, so you can save it as a binary file and load it as a file. Now, there's one thing I haven't shown you yet about file I/O. The old book covered it, and I don't remember seeing it in the new book here, so I do want to show you that, which was super cool. Because when we did our file I/O, we had to pick out all the individual options and write them as binary here. Again, specifically the binary format, not the text-based format. But there's a shortcut when we're dealing with classes, which is really cool. All right, so let me show you this here. So for item here, there's a quick thing we can do here. So if you are a class, right, so you have to be a class to do this. You can say you implements in interface here. So we implements the serializable interface. Serializable. There we go. The serializable interface from java.io.serializable. Big long word here. What serializable means is that you can essentially be turned into some sort of format that then we can write to disk or stream over the network. They can be serialized. Let's go define that word here, right? Why not? So define serializable. Excuse me. I love this little shortcut here. No, I wanted to define serialization, process of translating data into a format that can be stored, file memory data buffer, or transmitted. Look how cool that is. So you can make a semantically identical clone of the original object. Well, that sounds like fun. Okay, so if we are serializable, then let's go make one of these things here. Let's do an item coffee equals a new item given coffee 42 and 99 cents. And then we're going to do this try and catch thing. We're going to catch an IO exception. Exception, right? We have to do these try catch when we're dealing with our exceptions. We've done a little bit with exceptions from this chapter. Look at that. We're bridging right into our chapter here. And then we'll just, for now, we'll just print out the exception because that's fine. So if we're going to make a binary type file, right, I'm just going to go, oh my goodness. Let's just go look this back up here because it's not anything I have memorized. Let's do file IO examples. So we need a, here we go, a binary output file, data output stream. We'll add some imports here. If you just want to do io.star, again, that's probably fine here. That's probably a little faster here. This will be my item.bin file, and we'll make the file. Then we're going to call my binary output file. We're going to write, and we want to, what do we write in here? We can write my, oh goodness. Oh, where's my, oh goodness. It's in here somewhere. One of these methods, my binary output stream. Just write copy. Nope. Right. One of these methods here. Where is it? Hey, Danny. We're working on writing out some serialized classes here, and I'm not remembering the right method for it because I've got brain farts. Let me give me 1 second. Let me find it here from summer. We did it over the summer. No, I think, yeah. Oh, that one's still available? Cool. So, file IO. Write object. Oh, it's an object output stream. That's what it was here. So we have to use a different output stream. There we go. Given a file output stream, an object output stream equals a new object output stream here. Okay, so if you use an object output stream for writing serializable classes, you can say write. Goodness, I already lost the name of it here. Just write object. There we go. Write object. Write object given our coffee class here. Now, the catch here is that all of the properties must also be serializable. Serializable. All of your attributes must also be serializable. So in our case, strings, ints, and doubles are already serializable. It's done and built into the Java API. Right? We don't have anything really interesting here. If our class had another class as an attribute, that class would have to also be serializable. But in our case, they're just simple properties. And then we'll take our binary output file and we'll close it. Right? We open it, we rewrite, and we close it. Anytime we're working with files, do the right thing here. Let's give that a quick run. So we should now get in our files section here a item.bin. Awesome. So let's open this up. Didn't I have that shortcut here? Isn't there open? Nope. Okay. I thought I found a shortcut and I was like super excited that I found that shortcut. Item open in system? Is that it? Is that the... Oh, there we go. Yeah, we can open it with Visual Studio Code. Then we can do the binary file reading here. We should be able to see these values. Maybe. Sometimes it's hard to see them here in the binary file. And it says, yeah, we want to open it anyway, because it's not encoded in text. We want to do our hex editor for fun. See if we can't find some of these. There we go. So encoded into the file itself, you kind of see here is the class lab6 item. Right? The name of the class itself was kind of encoded in here, so we can go read this file later. We're able to go read it out. We can see there's a quantity. We can see there's a name. I don't see price in here anywhere, but it's somewhere in here. We can see the value of coffee. Right? That was the actual value here of our name. So somewhere in one of these blocks is going to be our price and our quantity. Somewhere in there. I don't know exactly where it is, but we're able to read them back out here in a minute. Okay, so if we come back to lab 6, let's do, okay, we did that one already, so I already have the file. Now to read it, this was the object output stream, we need an object input stream. Right, so I'm going to change this here to item 2, and then let's do an item input stream. So we're going to try make an object input stream. Stream. My binary input file. There's a new object input stream. Input stream given, given a new buffered input stream. What, Jibber? No. Go get your schoolwork done, please. All right, our buffered input stream given a new file input stream given the name item.bin. Right, that's a little long here, but we're going to try that. And then we're going to have to catch. I'll just copy our catch here. There. Okay, now we got it here. So we're going to open it, and then we're going to read it. So now I'm going to say item equals. Now this is a little bit funny here, but we're going to take our binary input file, and we're going to call read object here. Now the problem with read object is it only knows how to get an type object. So then we have to go and cast it as type of item. So hey, I really want this to be a type of item here. Now there's another exception that can happen. It says, hey, class not found exception. It has to be declared caught or declared to be thrown. So we're going to add one more catch here as a class not found. Oh, my cat's getting into trouble again. Class not found. Item and item. And then our item class, we have a toString method. So let's just print out our toString. So we can print out item. Okay, and then let's close it as well. So we'll do our binary input file .close. Okay, let's give that a run. So this is going to write to item 2, but we're going to read item 1, and we see coffee for $1.99 or 99 cents. So this idea of implementing serializable means I can really quickly write this as a binary object to a file somewhere. The old approach, right, would have had, okay, let me get out a value, let me get out a value, let me get out a value. I could write them individually as a binary format, which is okay. There's nothing wrong with that. But this is a handy little shortcut for us. So either approach is perfectly fine. So let me add a note in here then for our midterm practice. Where did that one go? So this is lab 6 for the easy approach, right? So you just implement serializable, and you can write it to disk, and then you can load it. Okay, hey, let me you know, this is your saved favorite sandwich or something. You can save to disk and then go order or whatever you want to do here. We got some options. Okay, so we save that. Oh, I should add a little bit more to the topic here. So let me go edit it. So it'll be open all week. Open all week, and that's next week. So that puts us at 2/22 up till the week after that. Then is 2/27, 10 a.m. Right? No, 29. There's not 29 days, so that's March 1st then, right? Yeah. That's 7 days. Wow, February is a weird month. Weird month. So you can save it and come back to it back anytime before the due date. That make sense? Hi, Moxie. You gonna come say hi? Here. You come say hi to everybody? Here, everyone wants to say hi. Oh, come say hi. Oh, baby girl. So she just had a birthday yesterday. She's one of my little kittens, although she's not so little anymore. Okay. You didn't want to come say hi. All right, I'll save that. So we can spend a little bit of time next week. No, not next week. Thursday, if you want to talk about this. We got to talk a little bit more about exceptions. Hey, Moxie Kaiser says hi. Kaiser? I'm sorry, I'm not sure how to say the name, but hopefully it's okay. Please correct me. I'm happy to say it the right way. All right, so the basic try-catch exception stuff we've gotten. So on Thursday, then, we're going to look at the more interesting, advanced try-catch stuff and look at how classes can use them, and then look at some new specific types, and then we can call it good. So I do want to add that exceptions quiz for you folks. So what do you think if I post it today, but it's not due until next Tuesday? That way you can get like automatically scored and things before the midterm. Does that sound like a good plan? I post the exceptions quiz today, because that way you'll have it available, right, for reference, and I'll make sure you can go back and see those questions and stuff. Hi, Moxie. Do you actually want to say? Oh, did Jubilee close the door? Are you stuck? She's locked in my office. Now she's sad. Okay, that sounds a good plan then. All right, so I'll post that one here in a second. Just exception quiz. Let's leave myself a note here. All right, any other thoughts, questions, or concerns? If not, I'm okay calling it a day. There's nothing new yet to practice for lab. So we'll come Thursday then, we can talk about exceptions, talk about the lab. We'll have lots of time for it. It's not too much left with exceptions because we've already done some of the basics, right, when we're working with files. It's kind of silly we take this one after. The ordering's a little funny here, but trying to do his chapters out of order is a little rough sometimes. Yeah, so how's that feel? I'll just keep saying a lot. I'm drinking my coffee. Okay, so let me go and update this one here. So this was added file IO to lab 6. Commit and push that. All right, well, we call it good then. We'll come back on Thursday because we do have to wrap up project 1. Right, that one's due, I believe, Thursday, if I remember right. Yep, so project 1's due Thursday. We can talk about that as well, the solution, and we'll talk about the rest of exceptions. And we go from there, okay? And I'll work on getting these graded for you. I'm sorry, I'm so far behind now. We'll be getting back to those. So, all right, let me know if there's anything else I can do for you, folks. If not, you take care, and I'll see you Thursday.